Hello everyone, this is Leo. I want to share my final project for the experimental AI course I took university. This project aims to explain in-context learning for large language models. This triangle with a green color is inspired the concept for deep neural networks. So for deep neural networks, the shallow layers and the deep layers they are responsible for processing different levels of information, and also that apply to in-context learning. So what is in-context learning? It is the ability that large language model can perform a task by observing the patterns in the demonstrations in the prompt. For example, this is a translation task. I provide some examples and it can make predictions based on the provided examples. So with in-context learning, we can generalize a large language model to a new task without pre-training or fine-tuning the parameters. So it is a very low cost. So why explaining in-context learning is so important? So for in-context learning, we just input the prompts and the model will make a prediction. It's a black box process. So what information models are used for making a prediction where is unknown. So maybe it can utilize some biased or toxic information in the prompts. So the transparency of this process is very important. And also, if we understand how this works, we can use it to guide the prompt design to benefit our downstream task. So what makes today's project unique? There are already existing a lot of large language model interpretation tools like transformer lens, large language model visualization, and the learning interpretability tool, but they are not specifically designed for explain the demonstration to word mapping. So they don't provide some useful interpretation about the in-context learning process. So for our repo, we incorporate for cutting-edge models that's specifically designed for interpret the in-context learning. The first is label words are anchors. It's funny that for the shell layers, for example, this is a sentiment classification test. In the shell layers, the larger model mainly focuses on aggregating information from the demonstration words to the label words, and in the deep layers, the information in the label words will be further aggregated for make a prediction. The second model is post-hoc explanation. So it focuses on like some prompts, some demonstration that the model makes a wrong prediction, but with high confidence. So this model can further uh, extract some explainable words from the demonstrations to correct the model. So with this tool, you can uh, benefit your large language model's reasoning ability on the downstream task. The third paper is large language model are latent variable models. So basically, they learn some explainable latent concept from the demonstrations. And further, it selects some useful demonstrations in the demonstration pool that are relevant to that latent concept. That means that demonstrations will benefit the downstream task greatly. So in such a way, you can select some demonstrations from your demonstration database to benefit your downstream task. The last model is identifying the semantic induction heads. So it explores the relationship between layers and heads in the attention modules and explore how they capture the syntactic and semantic relationship in the tokens. We can see some examples. This is my repo, and you can run the code in the Colab. For each model, it has a unified SDK. You can just input the model name and input your prompts, and you will generalize very good visualization for the results. Yes, this is my project. If you have any questions, feel free to contact me.